right, so here is our second reaction. This is the neutralization of amines. So our reaction, this should be sound familiar from 1201. Our process is a metathesis, and it is a neutralization reaction. So what you are doing here is you're taking a weak base, reacting it with an acid. Remember that the nitrogen has those lone pairs, which means that it can accept a proton from an acid. So an H plus from the acid is going on to the nitrogen, and that is going to give us a salt. It's going to give us an ion. It is going to give us, in this case, methyl ammonium chloride. And if you take a look at the MolView map that we've downloaded here, the methylamine, clearly very polar. You can see distinct blue regions and red regions, which means you've got electron distribution. As soon as it reacts, what you have is two unique ions. You have the amine, which has turned into an ammonium ion, and then you have a chloride ion. And so you can see that the methyl ammonium is blue and that your chloride ion is red, indicating that you've got now two ions that have a full charge. Okay, so just like the last one, you should pause this, make sure that you can answer this question before you watch me do the explanation. Okay, so I've got triethylamine reacting with hydrochloric acid. So my triethylamine, I've got 3 ethyl groups on my amine. And just because we're practicing, I want to draw in my lone pairs on my nitrogen. This is reacting with hydrochloric acid. So again, that hydrochloric acid is going to donate or give its H plus to the amine. Notice I do not have an equilibrium arrow here. This is a going in one direction arrow, and this is going to produce my salt. So my hydrogen from the acid, oops, and it still has my chloride. So since this accepted a proton, it is plus, and I still have a negative chloride ion.